Hey, welcome back. So I've got a project coming up that I'm going to need a little bit of power for, and I figured it's time I repaired one of my old power supplies. Right here I've got a 25 amp, 12 volt power supply, switch mode, that was a rescue from the trash. Turned out there was only, one or two things wrong with it, and as you can see here, we had a blown bridge rectifier, and of course a bad fuse, since that had shorted out. So I figured I'd bring you along while I go ahead and get this thing fixed up, and we'll see, what we end up using this for down the road. Alright, so let me get into this, and then we'll go over what we've got to fix. So there we go, we've got it all out of its housing. Most of the connections were all spades here, so they weren't all that difficult to get apart. Put the switch back on so I don't forget the wiring arrangement there. But here is our board. It's a single-sided board, which is not uncommon, for most power supplies there. We've got a big silicone pad here underneath all of our power components, which will be our 4 diodes and our FETs there, and I'm getting thermal grease on me already. I've already redone that grease once. I had this apart the first time, just trying to locate the problem, which was easy enough. Again, just the one bridge rectifier. I'd put in what I had at the time, which was not rated correctly for this. This is not rated for the current that this thing's going to draw, so I had not put in the correct value fuse until I had fixed that. I'm also going to move the fuse. I really don't like having to open up the housing to replace a fuse, and I've got some panel mount fuse holders, so I'm going to drill a hole and put one of those in, instead of having to open the case every time a fuse blows. I don't plan to blow it very often, but just a quality of life improvement. Otherwise, this is a pretty straightforward board. We have our bypass capacitor, a pair of common mode chokes leading into the rectifier, our nice beefy capacitors there. Each one of them being 200 volt, 820 microfarad. And while I am speaking of those, this thing has been wrapped up for a very long time, but I would rather spare the risk and make sure they are discharged. There we go. But otherwise, simple enough. This is a 25 amp unit. It's got a little bit of active cooling. It's got a small DC fan in the back there, which I believe is actually variable speed. It is controlled by the temperature that this is reading, which is actually supported by the fact that we've got a thermistor leading right over to the fan controller there. The FET or linear regulator, whatever they've got on there. But yeah, let me heat up the iron. We'll get out the bridge rectifier, get in the new, which I have sitting right here. Same package, different ratings though. Not as high of a voltage, but higher current. So again, we're going to time lapse this. I'm not going to make you sit through the whole thing. And we'll see you once we've got that replaced. And there we go. So I've put in the new bridge rectifier. A little bit of fresh thermal paste there on the heatsink. That heatsink was, I believe, something that I put on that was not on here originally. Of course, these diodes take a lot of stress here. That's what failed the first time, so I want to give it a little bit of an extra chance at a long life after this repair. And as for the fuse, I just went ahead and I swapped the terminal for the incoming line over to the other side of the fuse holder. So instead of having to bridge from the old line connection through the fuse, we're going directly into the board here. That way I can connect up my fuse holder using a little spade jumper, which I'll do now. So let me set this back onto the casing there. We'll take a look and see where we can fit that fuse holder. And then I'll go ahead and drill a small hole to accommodate that. The only thing to be concerned about there, other than the fact that I left that screw in there so I wouldn't lose it, is being able to get this thing back out of the case. So if I do put a fuse holder right here in the back, that's a nice open spot where I could do so. I want to make sure to keep it a little bit high so I've got enough room to tilt out the board. Alright, so let me dig out a panel mount fuse holder, the right value fuse. I'll drill a hole and we'll get that put into place there. so everything's back together there. We've got some more fresh thermal paste on the this heatsink we've got here. We've gone ahead and put in our panel mount fuse holder. Got that tagged in, running directly in, bypassing the old fuse holder on the board, linked into the old one, so I didn't end up cutting any wires. Kept everything, everything's there, so I can always rearrange that if I want to. So now it's time for the moment of truth. I haven't had this thing running in years, and as for the unit itself, if you can read that, that's our date code there. What's it now? August of 2007 is when this thing was made. And this had a hard life. It sat underneath the counter, powering a whole display of GPSs and everything else until she finally gave up the ghost. But hopefully we found it and stuck it back in. So let's plug it in and see if she goes poof. Shielding the eyes. So far so good. Looks like we have life. Yep, our fan's going there. Let me grab my meter here. Of course, my leads are underneath everything I've just been working on. There we go. And let's see what we've got on the output. 14.2 volts. That's a little bit high. I'd rather this run at 13.8. Let me do something here. Yeah, this is of course still live. Let me just secure the lead so I can watch what we're doing here. Like that, a nice soft start. And where is the appropriate screwdriver? Right here. Let me reach into this adjustment pot and see what we can do. Oh. That screwdriver doesn't actually fit. Alright, I think this blade will fit. Let's bring it to 13.9. Close enough. Better than 14.7. I know that's fine for a lot of things, but I'm going to be using this for battery charging. And at 13.9, if I forget this on a gel cell or lead acid, I won't have to worry about anything. So, it looks like we have had a success. Yeah, I could of course put this under load and see what we get there. But everything else on this, it seemed fine last time I took a look at it. So let me get this package back up, and this will be ready for the next time we need a little bit of 12-volt power. Alright, I'll see you next time.